In part 12, we covered how a large language model gives you answers. But answering isn't the same as doing. This video is about the next step, AI systems that don't just respond, but act, checking things, calling on tools, coordinating with other systems, and getting a task done in the real world. That's what's called Agentic AI, and this video maps how it works. Welcome back to the Artificial Intelligence Institute Africa AIIA, pronounced Aiia, Ubuntu Guild videos on AI. I'm Dr. Dennis Magaya, Chairman Aiia. This is part 13, Agentic AI. How AI systems move from answering to doing, coordinating models, tools, and workflows along the way. Recall the large language model, LLM, from part 12. You send it a message to an LLM, it replies, and that exchange is done. An AI agent takes that same underlying model and puts it inside a loop. Instead of one message and one reply, it decides on a step, checks what happened, and decides on the next one for as long as the goal takes. Checks what happened and decides on the next one for as long as the goal takes. And decides on the next one for as long as the goal takes. An AI agent is a system that pursues a goal by taking a sequence of actions, such as calling tools, checking results, and adjusting, rather than producing a single response and stopping. In plain words, an LLM answers a question. An AI agent goes and does something, checking its own work along the way, not the same as a workflow. It's worth being precise about what makes this different from ordinary automation, because the two get confused constantly. An irrigation timer that opens a valve at 6 in the morning and 6 in the evening. Every single day is an automated workflow. A fixed sequence someone wrote in advance, followed exactly, regardless of whether it rained overnight or the soil is already soaked. It doesn't reason about anything, and it doesn't learn from data or experience. It just runs the steps it was given. It brings speed, efficiency, and scale. A farmer checking the soil and the sky each morning before deciding whether to irrigate at all is closer to what an agent does. The decision isn't fixed in advance, but it depends on what's actually observed. And the same morning can lead to a different action than yesterday's did. A workflow steps are decided once by a person ahead of time and technology executes. An agent's steps are decided fresh by the model based on what it just observed, which is exactly the loop from layer 1. This is also where the difference becomes concrete. A large language model on its own takes text and produces text. That's the entire transformation part 12 described, however fluent the text is. An agent takes a goal, often expressed in text, and produces an action in world. The output isn't another sentence anymore. It's a changed state in a real system that stays changed after the conversation ends. Simply put, automated workflows run same steps. No matter what happens along the way, an agent changes its next step based on observation, learns, reasons, and where an LLM turns text into text, an agent turns text into action. Deep learning split into different architectures, built for different kinds of data. CNNs became the standard for images. RNNs were the standard for language until the transformer. The architecture behind part 12's attention mechanism, because it can weigh every word against every other word at once. Nothing about what's doing the thinking changes. What changes is action. What changes is what that thinking is allowed after the action. We are covering 4 layers today. Layer 1 is the agent loop, how a single agent decides what to do next, one step at a time. Layer 2 is orchestration, how several models, tools, and workflows get coordinated to work as one system. Instead of as scattered parts. In summary, orchestration means making sure the right specialist handles the right part of job in the right order, not making one model try to do everything itself. Now control planes. That shared trade tongue is what the Model Context Protocol, or MCP, does for AI agents. Instead of building a custom one-off connector every time an AI model needs to talk to tool, MCP gives every agent and every tool a common language to speak so an agent can use it. Before a standard like this existed, connecting an AI system typically meant custom one-off code. MCP, introduced by Anthropic in late 2024 as an open standard, gives common way to talk instead. The same handshake. no matter which model or which tool sits on either end. Universal port. But shared language for talking isn't the same as permission to speak. MCP standardizes it. That's the job of a separate layer called a control plane, which governs three things. MCP is the shared language. A control plane is the checkpoint every conversation passes through, deciding what it can see, touch, and keeping a record. Layer 4, observability and autonomy risk. Let's start with Layer 1. Layer 1, the agent loop. Think of a tracker following a set of footprints through the bush. The tracker doesn't walk the whole distance blindly. They examine a print, reason. They examine a print, reason about which way the animal likely went, walk a short distance in that direction, then stop and look again, checking whether prints confirm, checking whether the new prints confirm the guess or call for a change of course. Reason, act, observe, and reason again based on what happened. That loop is close to how an agent works mechanically. A well-known framework for exactly this pattern called REACT, short for reason and act, formalized this for language models. Think through the next step in words, take action, look at the real result, and think again from there. The model isn't just generating. It's generating a plan, calling a tool, a calendar, a search function, a database, receiving the real result back as new information and deciding the next step, continuing until the goal is met or it decides the job is done. In simple words, an agent doesn't guess an entire answer up front. It takes one step, looks at what happened, and only then decides on the next. Let's now look at orchestration. Layer 2, model orchestration. Think of a foreman. The foreman doesn't lay every brick, wire the building, and fit windows personally. They bring in a mason for the walls, a carpenter for the roof, an electrician for the wiring, and coordinate the order and timing. So all of it comes together into one finished house, rather than the wiring going in before the walls exist. A single large language model is rarely the whole system in Agentic AI. More often, one model plays the foreman's role, deciding what needs to happen next and which specialist to call on. While other models or tools handle the specific jobs, one searches the web, another queries a database. Another might be a smaller, faster model handling a narrow, repetitive part of the task. This coordination is called orchestration, and frameworks built specifically to manage it, among them LangGraph and Microsoft's AutoGen, have emerged precisely because getting this coordination right is often the difference between a finished house and a building site where nobody agreed on the order of the work. In summary, orchestration means making sure the right specialist handles the right part of the job in the right order, not making one model try to do everything itself. Now let's look control planes and MCP. Layer 3, control planes and MCP. Picture a river valley with a dozen villages, each holding its own market day and speaking its own dialect. In the old days, a trader from the pottery village who wanted to buy grain from the farmers, sell cloth to the fishers, and trade iron tools with the blacksmiths needed a different translator for every single pairing, one who knew pottery speech and farmer speech, a different one for pottery speech and fisher speech, and so on. Every new village added meant training yet another translator just for that one relationship. Then the villages did something simpler. They agreed on one common trade tongue, taught and understood at every market along the river. Now any trader from any village can walk into any other village's market and just speak. No dedicated go-between required for each new pairing. That shared trade tongue is what the Model Context Protocol, or MCP, does for AI agents. Instead of building a custom one-off connector every time an AI model needs to talk to a new tool or data source, MCP gives every agent and every tool a common language to speak. So an agent that's never encountered a particular tool before can still use it, without someone building a bespoke bridge first. Before a standard like this existed, connecting an AI system to a new tool typically meant writing custom one-off code. MCP, introduced by Anthropic in late 2024 as an open standard, gives AI systems and tools a common way to talk to each other instead. The same handshake, no matter which model or which tool sits on either end. Anthropic has described it as something like a universal port for AI applications, the same way a single cable standard replaced a drawer full of incompatible chargers. But a shared language for talking isn't the same as permission to speak. MCP standardizes how an agent and a tool communicate. It says nothing about whether that communication should be allowed, monitored, or recorded. That's the job of a separate layer called a control plane, which governs three things: context, what the agent currently knows and can see; access, what data and tools it's permitted to reach; and execution, what actions it's allowed to carry out. Think of MCP as the common paperwork format every trader now fills out the same way at every border post, and the control plane as the actual post itself, checking those papers, inspecting the goods, and logging every crossing before anything is allowed through. Say it back in plain words: MCP is the shared language agents and tools used to talk. A control plane is the checkpoint every conversation still has to pass through, deciding what it can see, what it can touch, and keeping a record of what happened. Layer 4: observability and autonomy risk. Think of a village slowly giving a young herder more independence over the cattle. At first, walking beside the herder every day. Later, only checking on the herd every few days. Eventually, letting the herder take the herd out for a whole season alone. Because this payment crosses a threshold set in advance, the guardrail built into that checkpoint doesn't let it through automatically. It pauses and asks a person to approve it, exactly the way the elders stayed close enough to step in, before the herd wandered somewhere it shouldn't. Once approved, the booking completes, and every single step, the reasoning, the tool calls, the pause for approval, the final confirmation, sits in a trace log a person could review afterward, end to end. Say it back in plain words: one real task just showed all 4 layers working together. A loop that reasoned and acted, a specialist called in for its job, a checkpoint that controlled what could happen, and a record of the whole thing a person could check afterward. Putting it into practice: how to build one. Think of opening a new workshop. You don't hand an apprentice a vague wish and walk away. You write a clear brief, hire the right specialist for the right task, and check the work as it goes. Building an agent follows the same order, and it starts smaller than most people expect. Step 1. Write a short system prompt stating the goal plainly, the way a clear brief does. You arrange courier deliveries for rural clinics. One tool available, courier check. Step 2. Define that tool precisely. A name, one-line description, and the exact inputs it needs. The same way a workshop specifies exactly which materials an apprentice uses down to the exact measurements. That's genuinely all a tool definition is: a name, description, and list of inputs in structured text. Nothing about it is more complicated than that description makes it sound. Subscribe to our AIIA YouTube channel and to Cognify.